In this presentation, we have talked about Pauli's neutrino hypothesis. While beta particle emission is concerned, the emission can be taken place in three ways. One is negatron emission, second one is positron emission, and the third one is casual electron capture. During the beta decay process, the quantity is energy, linear momentum, and angular momentum are not conserved. To solve these difficulties, Pauli introduced the concept neutrino hypothesis. Now, see this representation. When a nucleus emits a beta particle, a neutron in the nucleus changes into a proton, thereby increasing the atomic number by unity, keeping the mass number the same. Here, this is the parent which emits an electron. Then the atomic number is increased to 1 unit. That means proton number is increased, whereas there is no change in the mass number. Mass number is the summation of proton and neutron numbers. During this process, a neutron is converted into a proton with the emission of an electron. Now, some of this proton is H11, H11, then E minus, you may get 0 atomic number. Then there is no change in the mass number. A nucleus is not having an electron inside it, even though it emits an electron. This is due to the fact of conversion of neutron into a proton. During this process, monoenergetic beta rays are expected. That means beta rays with the same energy. However, the spectrum is continuous, implying that electrons emitted in the beta decay process do not have the same kinetic energy. We are analyzing the kinetic energy of the electrons coming out of the nucleus. They are having different values, not the same value. Here, the energy of the electron is given by the formula mass of the parent minus mass of the daughter into c square. This is called as disintegration energy. According to this relation, all the beta particles from the given radioactive substance must be emitted with the same kinetic energy, because MP, the mass of the parent, then mass of the daughter, are fixed throughout the process, so that the electrons coming out of the system should have the same energy. But measurements show that only a few beta particles are emitted with the maximum value. Most of the beta particles are emitted with the small energies, which means that all the beta particles are not having same energy. Now come to this diagram. Here the x-axis represents energy in MeV. Y-axis indicates number of beta particles emitted. The curve represents that more and more particles are lying in the low energy region. Only few number of particles are having high energy region. This represents all the emitted beta particles are not having the same energy, but the beta particles are coming out of the nucleus with a different energy range. The beta ray spectrum is therefore continuous, having energies ranging from 0 to a certain well-defined maximum limit called endpoint energy. This represents the non-conservation of energy. That means energy is not conserved. Next we may go to the conservation of linear momentum. If the parent nucleus is at rest and decays into a daughter nucleus and electron, the sum of their momenta must be 0 according to the conservation of momentum. See, this is target which is at rest, so the momentum of the target is 0. then which gives a daughter and an electron. Then if you sum up the moment of the daughter and the electron, that should be 0. If you expect 0 momentum, after summing up these two momenta, that indicates that both the daughter and the electron are having the same momentum value but opposite in direction. Momentum value should be same, but they may move in opposite direction. Then only the resultant momentum is 0. But observations show that they do not leave the disintegration sites in opposite directions. Thus, there is a violation of conservation of linear momentum. Next, go to our conservation of angular momentum. The nuclei having even mass numbers have either 0 spin or integral spin. The nuclei having odd mass numbers have half integral spin. As the number of nucleons in beta decay remains unchanged, the mass number remains unchanged. How can a nucleus of even mass number give you a daughter nucleus of the same mass number and an electron with half spin? To understand more about this, see this equation. Here carbon 614 is having even number of nucleons. It is a boson. Nitrogen 714 is also having even number of nucleons. Carbon 614 is converted into nitrogen 714 with the emission of an electron. This is beta decay process. Here there is no change in the mass number, but the additional electron is having the angular momentum value of h cross by 2. The angular momentum of this electron is h cross by 2. If you sum up the angular momentum of these two, we can get a fermion. Carbon is a boson, nitrogen is also a boson, but if you add an electron with it, the total is treated as a fermion. This violates the conservation of angular momentum, because carbon is having even mass number, nitrogen is also having even mass number. If you add an electron of angular momentum h cross by 2, this is converting a boson into a fermion. This violates conservation of angular momentum. In this way, energy, linear momentum and angular momentum are not conserved during beta particle emission. To solve this difficulty, Pauli introduced the existence of new particle, the neutrino. The antiparticle of neutrino is antineutrino. The antineutrino comes out of the nucleus simultaneously during beta particle emission. Neutrino and antineutrino have 0 s mass and carry no charge. They have an angular momentum value of h cross by 2. Likewise, electron, neutrino and antineutrino are also having the angular momentum value of h cross by 2. Since the neutrino has 0 rest mass, it moves with the velocity of light and hence its linear momentum is p equal to E by c. To understand this, consider the relativistic Hamiltonian E square equal to c square p square plus m0 square c power 4. Here the rest mass equal to 0. Since the neutrino has 0 rest mass, then E square is equal to c square p square, E equal to c into p. Therefore, p equal to E by c. Just take the positive root alone. The neutrino is a particle with its spin vector anti-parallel to its momentum vector, whereas the antineutrino is a particle with its spin vector parallel to its momentum vector. In this way, we may distinguish a neutrino from its antiparticle antineutrino. According to the neutrino hypothesis, the nucleus emits an electron and an antineutrino when the neutron is converted into a proton. In this reaction, the concepts energy, linear momentum and angular momentum are conserved. The nucleus emits a positron and neutrino when a proton is converted into a neutron. As we pointed out earlier, a nucleus is completely free from the electron. However, it emits electrons. This is due to the fact of conversion of neutron into positron. If you talk about positron emission, a proton is converted into neutron. Therefore, always the conversion of neutron into proton and proton into neutron is taken place inside the nucleus. In this reaction also, the concepts energy, linear momentum and angular momentum are conserved. Now we have to talk about the conservation process. First, we should talk about conservation of energy. The electron and the antineutrino carry the total disintegration energy. The Q value is shared by the electron and antineutrino. The electron will have the maximum energy when the energy of the antineutrino is 0. The sum of the energies shared by the electron and antineutrino should equal the disintegration energy Q. This could be the reason behind the continuous beta ray spectrum. Now come to our spectrum. See here, most of the beta particles are lying in the low energy region. Only few number of beta particles are lying in the high energy region. The disintegration energy is being shared by both the electron and antineutrino. If the antineutrino consumes more energy, only a few amount of energy is given to the electron. Suppose the electron consumes more energy, only a few amount of energy is given to the antineutrino. In this way, we may get electrons with different energy levels. That means energy from 0 to a maximum endpoint energy. This is the reason for continuous spectrum. In this way, energy is conserved. Next, come to the conservation of linear momentum. The vector sum of linear momenta of a daughter nucleus, electron and antineutrino must equal 0 since the momentum of the parent nucleus is 0. It is assumed that the linear momentum of the daughter nucleus, the electron and the neutrino must be capable of representing the three sides of a triangle. The electron and the daughter nucleus don't need to leave the decay site in opposite directions along the same straight line, because in any way we may make the vector sum equal to 0. In the beta particle emission, without the consideration of antineutrino, the momentum of the target is 0, the momentum of the product, that is the daughter and the emitted electron, should also be 0. To maintain that, both of them are expected to have same momentum value, but they may move in opposite directions. But observations indicate that they are not moving in the opposite directions. With the introduction of the particle neutrino, Pauli representing the momentum process with the help of a triangle. There is no need for the daughter nucleus and beta particle to move in opposite directions, because if you make the vector sum, that may be providing 0 momentum. In this level, the linear momentum is also conserved. If you take the particle antineutrino in our account. Next, consideration of angular momentum. The angular momentum of the antineutrino is h cross by 2. When an electron and an antineutrino are ejected, the total angular momentum loss is h cross. The resultant angular momentum of all particles left after the decay is integral or half integral, whether that of the parent nucleus is integral or half integral. Thus, the total angular momentum can be conserved. To understand this, consider the equation. Carbon 614 is converted into nitrogen 714 with the emission of electron. Without the emission of antineutrino, if you discuss this reaction, this is a boson because of this even mass number. Here nitrogen 714 is also having the even mass number. That means the number of nucleons is even. In addition to that, proton number is increased by 1 unit, 7. So that the combination is a fermion. -1, 0. If you add an electron with the nitrogen, this combination is a fermion. Here the left hand side is a boson. Now if you treat this with the inclusion of antineutrino, carbon 614, nitrogen 714, electron is antineutrino. The spin value is h cross by 2. This is also having the spin value of h cross by 2. This is a left hand side is a boson. Now the summation of all this provides a boson. Now the angular momentum is also conserved. In this way, Pauli successfully explained the conservation of energy, linear momentum and angular momentum with the introduction of the concept neutrino.